Okay, first of all, we probably aren't going to name it Prometheus. We're in the middle of a hot debate over what to name it. Personally, I like Brutus. That's a joke. We're competing against Caesar, New Frontier. Also, I will mention that the deputy PI is Lynn Carter from LPL. Succession is important for these long-term missions, especially when the PI is experienced. Okay. So this is built on the Io Volcano Observer mission that we proposed in Discovery. And we earned a Phase A study from that. And this did very well. Our slogan was "Follow the Heat." Our cat is very good at that. Next slide. Or shall I do this? Okay, so why Io? Io has more than 100 actively erupting volcanoes, that are much more active than those on Earth. The least active of these is comparable to Kilauea in Hawaii. Includes very large, the longest active lava flows in the solar system, comparable to flows from Earth's past. Why is Io like this? The intense volcanism is driven by tidal heating from the 421 orbital resonance of Io, Europa, and Ganymede. Io's globally average heat flow is at least 20 times larger than that of Earth. There's large-scale silicate and maybe ultramafic volcanism, similar to all of the early terrestrial planets and many exoplanets. There's a unique style of tectonics. It produces the densest plasma torus in the solar system and a highly dynamic electromagnetic coupling with Jupiter. So a better understanding of Io would advance our understanding of many other worlds, including the tidally heated ocean worlds with largely silicate interiors like Europa and Enceladus. The early terrestrial planets such as Venus and Earth and Moon, and exoplanets, including magma ocean exoplanets or systems with tidal heating like the TRAPPIST-1 system. Io is the best place to study tidal heating because it has the highest tides, larger than the Statue of Liberty if there is a magma ocean with a detached lithosphere. It has the greatest heat flow, most intense volcanism, the biggest volcanic plumes, the longest active lava flows, the tallest actively uplifting and falling apart mountains, the greatest volatile loss, and the strongest magnetic interactions. So in other words, there's lots of stuff to measure there to understand tidal heating. So I said we proposed Io Volcano Observer in Discovery. We did a Phase A study. We got lots of accolades, but it was not selected to proceed. And the associate administrator said this was because of concern about the APL Applied Physics Lab workforce with Dragonfly, which they keep delaying, and that's the problem there. You probably should have been more concerned about the JPL workforce for those of you following recent events, but nevertheless, we didn't go forward. Fortunately, Io is a destination as part of the New Frontiers 5 competition. So the Jupiter tour was optimized to understand tidal heating with a highly elongated, elliptical, and inclined orbit about Jupiter with fast, close flybys of Io. This minimizes the radiation dose and provides excellent views of Io's polar regions, which is especially important for distinguishing between tidal heating models. And all of the encounters were timed and located specifically to measure key parameters, something that other missions that happen to visit Io once or twice cannot do. On the bottom right are the ground tracks. Yellow is illuminated by sunshine, blue is nighttime, light blue is illuminated by Jupiter shine with low phase Jupiter, which together gives us global coverage. So here's a candidate tour with 20 encounters that we might be able to propose for New Frontiers 5. We can pay for the radiation design with the higher cost cap to support 20 encounters. I'd love to talk in detail about all the things we do in this The names there are all active volcanic centers and mountains on Io. So here are the IVO science experiments. There were 6 of them, plus gravity science was very important. So there's a magnetometer, plasma instrument, wide-angle camera. That was a student collaboration instrument to be built at U of A. We probably propose a student collaboration instrument in phase A if we get there. Thermal mapper, narrow angle camera, and a neutral mass spectrometer. So how do we augment this mission for New Frontiers? We like the same inclined orbit like IVO with multiple IO encounters. We'll add Ka-band telemetry for better radio science and more than 2 times faster data return. The enhanced radiation design to survive a total higher ionizing dose, the increased number of encounters, and increasing the cadence of the encounters with Ka-band. We can still get the data back in between each encounter. We're debating a number of potential new science instruments, and I won't say more about that, but something new will be added. So what's next? The draft AO was released in January. NASA is still saying the final AO will be released in November of 23. Hopefully there isn't a government shutdown. Proposals would then be due around March of 24, phase A selections in December of 24, and then concept study reports due in January of 26, and a new start in the beginning of FY 27. This is an especially drawn out process here, and this is because they don't want to have to spend significant money until FY 27, basically, given all of their other troubles. And so let's hope that they are out of trouble by 2027. I think that's unlikely, but they do seem determined to go forward with this competition, and they can always delay the start of the mission like they have for so many others. I'll stop there and take any questions. Tim?
I guess what's the best spatial resolution you have along a ground track, and what resolution will you have planet-wide?
Okay, the near global imaging coverage will be around a few hundred meters per pixel in the visible and a couple of kilometers per pixel in the thermal IR, which at nighttime, which is very important to us. The very highest resolution we can get is limited by the ground track speed, but it'll be better than 2 meters per pixel, which is substantially better than we have now. That again is in the visible and the thermal IR. Gosh, it's tens of meters.
Yell it.
Yeah, it's okay.
Assuming this moves forward in 27, when would you launch and be at IO? Give the range of when you'll be at IO.
So when we launch, right now NASA is saying launch period between 2031 and 2034. That could change. They are releasing a new community announcement soon here that might delay that further. It'll take us about 5.5 years to get there. We might need a Venus gravity assist with the extra mass that we have. So then it's the late 2030s, and then we have a 4-year prime mission, and then we expect to have an extended mission with a comparable number of IO encounters. So definitely like having a younger deputy PI.